Hi Team 3. So this video is about tectonic plates and how they move. How does this happen? We know that we have tectonic plates. We know the lithosphere is split up into them, and we know a little bit about boundaries between them, but we haven't really looked at how they actually move the way they do. Let's do a quick review of a concept that you might remember from the atmosphere and weather unit. Let's see if you can remember what this is all about. So we have our pot on the hot plate, and we're turning the hot plate on. We're going to heat up our water. And you guys might remember that when we looked at this before, the water at the bottom of the pot gets heated up first. And things that get heated up become less dense, and things that become less dense rise. And so you might remember doing this as part of your diagram. And we know that when the water gets to this top of the pot here, it starts to cool down. It's no longer in contact with the hot plate, with the heat source down at the bottom, and it also loses its heat to the air above. And so it cools down, becomes more dense, and starts to sink. Remember this pattern. We'll just say you do. And this is not the end of it. So when the cool water sinks, it gets heated back up again, becomes less dense, and rises. Cools off, becomes more dense, and sinks. And this continues over and over and over again. So the transfer of heat through the movement, the circulation of a liquid or a gas, is convection. And so you probably remember that when it happens over and over again, it's called a convection current. So let's take a look at what this has to do with the movement of our tectonic plates. So if you take a look at this diagram, you can see the surface of the Earth, and you can see the interior of the Earth. And if you look at these red arrows in their circular patterns, you might be able to identify them as convection currents. So what's happening is the core is acting as the heat source, and the heat is rising towards the surface of the Earth where it's cooler. So it's cooling off and it's sinking, getting heated back up again and rising. So it's actually the rock inside the Earth, by the way, that's doing this. The rock is getting heated up and rising, and the heat's going with it and cooling off and sinking. So you have the same exact concept that takes place in the pot, taking place in the interior of our planet. And all of that movement, now it's really, really slow, of course. Everything with plate tectonics and geology is very slow in terms of time. But that rising, as it rises up into the asthenosphere, it creates a disturbance. It's a movement. And so that disturbance and that movement is going to transfer to the plates resting on top of the asthenosphere. So when the asthenosphere is disturbed, the plates on top are disturbed. You can think about like a leaf on a pond, and there's like something in the water, and it creates waves of energy, and it disturbs the leaf on top. And if you look at this, it's really interesting. If you notice some similarities between the direction of the convection current arrows and what you see going on top. So let's take this example right here, the mid-ocean ridge. So this is where seafloor spreading is taking place, and you may know that that's happening at a divergent boundary. So these plates are moving away from each other, and I want you to look at how that compares to the arrows down here in the convection current. Okay, this one is moving this way, and this one is moving this way. So there's some similarity there in terms of the direction of the convection currents and the direction the plates are moving in. And you might notice the same thing over here really quickly. This is the Nazca plate. This is a convergent boundary. It's colliding with the South American plate. Okay, Andes Mountains, big deep trench here. And you might see that lining up with the direction of the convection currents. Okay, so you have some cool stuff here. Let's take a look at another view. This is just another way of looking at it. You've got the convection currents inside the Earth disturbing the asthenosphere, and that is disturbing the lithosphere on top of it. And I like this diagram just because it includes some subduction. So you can see the plate sliding down here, being pulled into the subduction zone. Okay. And you can see the similarity in terms of the movement, the direction of the convection currents. Now, aside from convection currents, let's take a look at two other forces at work here and helping to make our plates move. So the next one is called ridge push, and you can see that label up at the top here. Let me just circle that for you guys. Oops. There we go. Okay. So ridge push is a really important force to know about. I want you guys to think about the mid-ocean ridge. I want you to think about it being a little bit higher. And when something's higher, gravity can help it go downward away from the ridge. So the plates are being pushed away from the mid-ocean ridge. Okay, so the new plate material at the mid-ocean ridges gets pushed away, and that force helps the plates to move. Ridge push. And then the third force at work here, along with convection currents and ridge push, is called slab pull. So the word slab, that's just another word for like a big chunk of land or a tectonic plate. And I want you to think about a plate being pulled. So here's the ridge, and it's being pushed away from the ridge. But down on this end, gravity is helping to pull it down, the denser plate down into the asthenosphere. And we know that that's called a subduction zone. So when the leading edge of the plate, leading edge meaning the edge that's going down into the subduction zone, gravity's pulling that into the asthenosphere at subduction zones. And that force is called slab pull. So we have convection currents creating a disturbance in the asthenosphere and disturbing the plates on top and getting them to move slowly over time. And then we have ridge push and we have slab pull. So those are your three forces working together, getting our tectonic plates to shift around the surface of our Earth. Okay, so now you guys are going to work on your 5, 4, 3, 2, 1 response activity. Good luck, off you go.